welcome also from my side. Looking into the soil with sensors. Is the microphone switched on? Or? Yes, okay. Looking into the soils with sensors. That is generalized, a little bit generalized title. The subtitle, I think, is more meaningful. Use of sensor technology for the investigation of soils. Before I start my lecture, 4 remarks. The first remark is look a few in the past. The development of sensors, of soil sensors, started nearly 40 years ago. In this situation, in the middle of USA and also Australia, the problem was that the great areas are affected by salt, by sodium chloride. Until this, this time, the measurement, the detection of this salt-affected soil were carried out with the determination of natrium, sodium, and chloride. But then the idea came up, the measurement of the degree of affection is also possible with a measurement of conductivity. And this was the, how to say, the birthday or the birth activity of soil sensors. The idea was to develop a device to measure conductivity with an on-the-going sensor. On-the-going sensor means with a tool which is placed on the earth and moved on the earth and detect the development of the conductivity. Conductivity is a central term within soil sensors. We will speak this in the whole during the whole lecture of conductivity. The second remark is reflection and absorption. Reflection and absorption is also very often used this technique within sensor technology, but it is also used of drones, airplanes, and satellites. But drones, airplanes, and satellites are not the objective of my work. My work is only proximal sensing. Proximal sensing is close to the Earth, directly above the Earth, less centimeters above the Earth, and in the Earth. The third remark is that that we measure this conductivity usually in how to say it. This moment, please. Yes, this part is not a part of the common soil science. The common soil science measured soil parameters only with measurements in soil profiles, which you can see here in soil profiles, or using a perk hour or with a drilling system. The drilling system here on the right-hand side, you can collect a soil sample as in form of a soil column. Now to the structure of my presentation. First, I will give you an overview of all relevant devices and techniques which are used on this area, with a more detailed look on often used technique. The second section is has a headline: sensor combination, sensor fusion. The background here is that no sensor can detect all relevant soil parameters. Therefore, the idea came up to combine sensors to one platform. And this is, that is called sensor combination or sensor fusion. The third part, sensors produces always proxy values, substitute values. They produce values, for example, conductivity, permittivity, resistivity values, reflection values, absorption values. But in this section, I will describe how we come from these proxy values to the relevant soil parameters. And in the fourth section, I will show you how we combine the maps at the end of the section 3. There we produce maps. In the fourth section, is a combination of these maps with other maps, geological maps, erosion maps, soil elevation maps, and so on. And the results of these maps will I show you at the end. Now, this is the overview of the most used technique: mechanical, electrochemical, optical, electrical, radioactivity, and at the end, acoustic and pneumatic. This is very not so often used. Oh, sorry. This is not so often used, therefore is a little bit fade written. Now, my intention is to focus my explanation on two techniques: optical technique and electrical technique. Optical technique is, I think, well known. We measure here the soil surface with light, with a source light or with sunlight, and measurements are always in the range of visible, or in the range of near infrared, and this is a new development in the range of middle infrared. Visible, you know it from the school, 400 to 800 nanometers, and below this until 2500 nanometers near infrared, and middle infrared is in the range a little bit above the near infrared. Measured is here always the reflection or the absorption light from the surface of the soil. And the end product of these measurements are here organic matter, also total organic matter. That means organic matter and mineral carbon connections. Additionally, the nitrogen content, and to a less extent, also texture and water content. Here, this slide shows you a typical reflection curve of soil surfaces. On the left-hand side, there's a profile here from the area between Freising and Pulling. There's a former flood area of the Isar River, and we can recognize a severe, vertical discontinuity. And every number on this soil profile corresponds with a number of this reflection scans here. For example, the number 9 is a very dark vertical discontinuity, and dark means high content, relatively high content of organic carbon. We can hear the higher the organic carbon, the lower the reflection curve, and vice versa. Here, number 7, a more bright vertical discontinuity. In German, we call this kind Mergelton, and here the reflection curves is very high. That means the higher the lower the organic matter, the higher the reflection curve. This system is very simple. It is often used, especially in laboratory analysis. Is a daily doing, I think. And outside is more or less a new technique. Here, this is a tool, it's a device, in which case we can measure the reflection absorption outside. This is a system which is developed by the University of Bonn, the soil science. And within this box, this is a dark box, the light influence is excluded, is a halogen light, and inside is also a spectrometer. and the spectrometer measures the reflections. This is a very easy system. This system is also used in the laboratory. Here we have a tool which is usable inside. This pistol here is inside in the laboratory, but also in the outside, for example, for the detection of a soil profile. Now, this tool here, this device, is developed in the former chair of plant nutrition. This is number 4 of this so-called phenotrack. And it was developed for the detection of biomass, of green biomass, but it's also usable for the measurement of bare soil. And here are some sensors. Here are some, for example, active sensor and the passive sensors. Both are also used for the measurement, the reflection measurement of the bare soil surface. Active means they have own light source, in this case in form of a flash, and passive means also the direct sun radiation is measured and combined with the reflection values. This, yes, in here this is a field in also between pressing and pulling, and what we measure is here on this field nearly size of 2 hectares, and we have I've forgotten the legend. Here we have severe gradation between north and south, and that means here a reflection of nearly 70%. In the case of 1970 nanometer, and here a reflection of nearly 30%. That means that we have a decreasing organic carbon from the south to the north. Now to the next, the next group of soil sensors, electrical sensors. This is the greatest group of soil sensors, and if you read today a publication, it is very great probability that you find in this publication this sensors here described. EMI means electromagnetic induction, ER electric resistivity, GPR count penetrating radar, TDR time domain reflectometry, FDR, frequency domain reflectometry. The last one are only usable for the detection of soil water. And if you use a soil water measurement unit, the probability is very great that you use this one of these both systems. The GPR is sometimes used, but the problem here was always until today that the results are so confusing that it's very complicated to interpret this measurement values. EMI is very often used. We're measuring here, the systems are measuring always electric magnetic conductivity, which is introduced in the earth. We can derive from these values the texture, so very often used, mainly clay, but also water content, and also the conductivity of the soil water. I will focus in the next slides of these 2 T types. Here is on the right-hand side, the electromagnetic systems are described, so-called inductive coupling. And the measurement unit of this inductive coupling and of all conductivity measurement devices is ECA. ECA means apparent electrical conductivity. This apparent means in a normal soil is consisting of a great number of different conductivity areas. There's mineral soil, content of humus, the soil water, the ion concentration is the soil water. Every part of the soil has only conductivity, but with these tools we measure only a space of one, the whole space of one with one conductivity. And therefore, this kind of conductivity is called aberrant conductivity. It is within the soil sensor technique a very often used, a very often described method. So here are these two main devices, both called EM38. The upper one is the older one, the lower one is a younger one. This is EM38, and the lower one is EM38 MK2. I have brought this second, the newer one with me. And so for the understanding of the measurement, it is necessary to give some explanation about these tools. We have this tool runs with batteries, 9-volt battery here on the side. Here we have two displays for the readings. Here are the buttons are for the calibration. Very important is that these three coils, so-called coils. The distance between is called is the half meter, and the distance to this from this to this is 1 meter. And this has a special meaning. Yes, and the meaning is that for every distance, measure a special depth and measure a special depth of the soil. Also important is the orientation of this coil. We can measure in this way. This is so-called vertical position, and in this way, this is a so-called horizontal position. But what does it mean? The next slide are here this point described. Every position detects a special depth of the soil. For example, here on the left hand, there is coil distance 1 meter, here coil distance a half meter. Here the red line is coil distance is a vertical position, the green line horizontal position, sorry. And we recognize here that 1 meter vertical position is mainly influenced by the conductivity values in a depth of 30 to 40 centimeters. And in the case of horizontal, the green line, this is mainly influenced by the conductivity values direct below the soil surface. And in the case of a half meter coil distance, the situation is a little bit similar. Here, vertical, nearly 20 centimeters, the main influencing area, and in the case of horizontal, a little bit closer to the soil surface. It is necessary to say that these curves are estimated by the producers of these devices. These curves were never controlled by other researchers because it's a little bit complicated to do it. And so this conductivity is influenced by the mainly clay content, the water content, the concentration of ions in the soil water, soil density, and what is very important, the soil temperature. And especially the soil temperature is necessary to take into account during measurements. How can we use this tool here? We see here two images. On the right-hand side, there's a field-wide measurements mounted on the tractor, and the EM38, the MK2, is here covered by a white plane. Below this device, and also in the surrounding of about 1 meter, this area is metal-free. As the whole equipment is until here free of metal. And here under this blue sack, there is the GPS. This is the alternative way for the measurements. This is a student. He measured the in South Tyrol the apple orchards of his family. Yes, and the using of a tractor was here not possible, and yes, the alternative is the only way is to get such conductivity values to make it by hand. Yes. What kind of pictures, what kind of values do we get with these devices? We have here this area research station. Dürnast is here, Freising is here. This is the road between Freising and Thalhausen, Allershausen. And this field are always, for my knowledge, always in the property of the Technical University. We have here ECA range. Here is measured vertical 1 meter, ECA range from 5 millisiemens until 60, 70. That's also the often observed, often measured range here in the surrounding of Freising. And we see here different severe values here in the so-called D5, or here in the so-called D13. I will show you better pictures, better images from the D1. This is this one, and here from this field, this are the long-term fertilization experiment Dürnast. So the next slide is here. We see here always vertical 1 meter, close conductivity, but some stripes and some patterns which are not so clear on the first view. But if you know that this street here is a terrace street, that means during the winter, de-icing salt, yes, is used, and partly this de-icing salt, this sodium chloride comes with the rain on the field, and this enhances the values. It's not so fine, this situation. Other one is this here, is stripes. What this is not clear. We assume that these are maybe former streets today, yes, tillering arable land, but we cannot recognize, we have no explanation for this situation here. So this next slide, I said that this areas of long-term fertilization experiments in Dürnast, and we have here all positions, all orientations with are possible: vertical 1 meter, vertical ½ meter, horizontal 1 meter, and horizontal ½ meter. And we recognize in all images very high values in the corner, or in the northwest, or northwest of the area. This correspondence, this high values correspondence with the higher clay content in this area. Usually we have on this whole area clay content from 12–15%, and on this area there are 30–32% clay content. And these 4 images give us a fine overview about the soil conditions of this experimental site. Here, a summary of these electromagnetic tools, of these EMI tools. Advantages is this easy handling, fast data acquisition, high performance, performance measurement, wide range of application. The disadvantages are not, are also severe in some cases. Temperature drift of the tool during the measurement. Calibration is necessary here, is not so easy to carry out. Values are relative values, and the relationships, for example, between ECA and clay are not transferable to other fields. That's a very important point. and the temperature of the soil must be determined. Measurement, I do it in this way, measurement, if possible, at field capacity, and cool ambient temperature is preferred. And the measurement values are normalized to 25%. These were the so-called AMI systems on the right-hand side. Now to the direct current systems, also called as galvanic coupling. I will not speak about the alternating current geoelectrics because the application of this system is very time-consuming, is very complicated, and therefore I will focus my explanation to this direct current geoelectrics. Yes, the system here is developed by the Leibniz Institute, Groß-Bären, in the south of Berlin. This device has a nice name, Geophyllus electricus, and I hope that you can recognize this. Is a little bit unclear. We have here different axes, and at the end of every axis there is a disc, and in this case this disc is toothed. This is important to get a better soil contact, soil contact. Here at the first axis is the transmitter coil, the transmitter a disc, and all other discs are the receiver discs. And the distance between transmitter and receiver coil determine which depth is mainly investigated. For example, here the first two axes determine mainly a depth of a half meter. The system of the next, all this kind of devices is always the same. Here also an axis, yes, in only one axis. Here also the transmitter disc are on the outside, and the receiver discs are in the middle. This is the same system as Geophyllus electricus. This is a little bit changed. Yes, not so much axis here. This is so-called soil doctor. I do not understand this name, but it is so. Is it so? And these are always on-the-go measurements. Yes, but we have also in this group of devices point-wise measurements. And this is here one example. There is a steel rod. I hope you can recognize this. And at the end of the steel rod, there is a sensor for the measurement of resistivity or conductivity. Usually, this system measures resistivity, but resistivity is the reciprocal value of conductivity. So it can also be possible that the conductivity values are here measured, are here given at the end of the measurement. So now some short description of further technique. Gamma spectrometer is today a very often used word. Radioactivity means the measurement of the natural radioactivity. Measured is here mainly, or not measured is a radioactivity radiation, but this the measurement unit, measurement values, measurement readings are correlated with clay, and to a lower extent also to sand and silt and sand, and also to some minerals, especially to potassium, and also in not all cases, but very often to calcium combination. So this is very easy to understand. Mechanical systems, diesel consumption, that means if you need during tillering more diesel, then you have a more clayic soil, and vice versa. Yes. Here is this system is also a point-wise system. A rod is pressed into the soil, and the energy which is necessary to press in the soil is related to the bulk density of the soil. Electrochemical. This is now my last technique. Electrochemical are electrodes. Electrodes for the measurements of they measure the activity of the ions in soil solution, and measurements this end product are the concentration of nitrogen, ammonia, and potassium, and also pH values. But pH values can we also outside measure without in dry soil, in wet soil. Yes, soil water mixture is here not possible. So, ladies and gentlemen, you have recognized that every technique, every method, every device measured a special relevant group of soil science, but no of these sensors can measure all relevant soil parameters, and therefore 10-12 years ago the idea came up to combine sensors in one so-called platform. And also this is also sometimes described as sensor fusion, and some of these sensor fusion system I will present here now. Here is, for example, a unit there's a shoe in the soil. This shoe opens the soil, and inside is a spectrometer. Here is the equipment for the measurement of the pH value, and here the well-known, meanwhile also for you, well-known disc for the measurements of resistivity. Here is a more is given again. Here is the shoe, yes, and here is the a light source, and this is a spectrometer. And the system is always, I think, the same. And here this picture indicates us in which way pH values are measured. Here, this system is pressed in this with earth fulfilled part of this equipment, and this result are the pH values. So this is the newest tool which we have here in Dürnest. I bought it nearly 2.5 years ago. It is called Varys P4000, and with this combined sensor, we can measure ECA, the cone index. Cone index means the penetration force to press this steel rod in the earth, and this system can also measure the reflectance from, in this case, 800 to 2500 nanometers. There's a closer view. This is the lower part of this rod. This is the cone here with the measurement of the penetration force. This is the measurement of the ECA, and here is the artificial light, artificial halogen light for the measurement of the reflections, for reflection value. This is an example from Friehausen. Along this line, all the soil samples are given here in the upper pictures. This is a little bit unclear, but I can explain it to you. Here in the y-axis, there is a depth from 0 meter to 1 meter. In the lower x-axis, there is the force, the force to press this rod in the earth, expressed as kilopascal, and in the top x-axis, this is the conductivity values. And with such measurement, we characterize a whole field, especially in the case for the interpretation of fertilization or of fertilization experiments. This is now, ladies and gentlemen, the absolutely highlight of sensor fusion. All what I want, all what I know, all what I hear this evening is combined on this one tool. It is called Heil4S, Intelligence for Soil. That means it's a joint project of the Great Bonaris project. And this tool is called Rapid Soil Mapper or Rapid Mapper. Here we cannot recognize so much. The next, yes, is also a nice picture. This here we can see a little bit more. We can start with our well-known disk, tooth disk. Here are the ion sensitive electrodes installed. Here is a measurement also is also the gamma spectrometer. Yes. And additionally, here on this other platform, there is a different hardware and with the encoding software. Worldwide, you will never find such a sophisticated device. No. So, my first interim results. As you know, meanwhile, every technique is measuring special proxy values. Sensor fusion avoid this disadvantage of too less measurement intensity, and this is my interim result. Now to the section 3. All these sensors deliver reflection values, permittivity values, resistivity values, conductivity values, but this, I said it a little bit before, these are only substitute values, only proximal values. How is it possible to come from these proximal values to soil relevant values? And this is described in the next slide. In the next slide, this is Grafenfeld, a field which belongs to the research station, research station Thalhausen. ECA measurements, vertical 1 meter. Vertical 1 meter, the values are here interpolated in a grid of 2 meters. And then, I cannot go further. Was? Habe ich jetzt nicht verstanden. Also that's my next slide. Then it is the next step of the evaluation is the taking of soil samples. In this case, we divided in calculation and calibration data set, and here this readings and the results of the laboratory analysis are combined. In this case, we can model the clay content with the application of ECA, vertical 1 meter, and the topographical value expect And in the case of sand and skeleton is a similar ECA, vertical 1 meter, and the topographical wetness index. And the results are nearly 0 point high. Only in the case of silt is a little bit lower. But after my experiences, it is necessary to add in the case of silt the so-called vertical, the so-called thickness of the quaternary sediments. This is a variable which is developed also in this system and means the thickness of the loess limb covering of these investigation areas. So the result is now, here's a clay map. We have a very, very great distance between 5% and 50%. This is very seldom that we have such a great distribution, or here's the distribution of sand and gravel. We can combine ECA values also with the yield. And this is shown here on this slide here. This is the upper image shows fertilized plots, and the lower low fertilized plots slowly, and the lower one high fertilized plots. Relationship between the old EM38 vertical, horizontal, vertical 1 meter, and so on. And the relationship is here given, and you can recognize especially the new device, the MK2. We can describe, we can model the yield distribution in this field experiment in a, yes, I think in a very good way. So, ladies and gentlemen, my second interim results. We have shown that the sensor application includes the derivation of a range of soil properties, and also under changing environmental conditions, for example, changing fertilizer level, and that we can explain with this technique also the soil formation and also yes, management of the agricultural land use. What do we now with these images, with this clay image, silt, and so on, and the own image with this image of the distribution of organic matter or nitrogen content? This is included in a flow, in a stepwise flow chart here. The end product are the so-called theme layers, is once for a soil scientist with the soil type description, geological substrate, hydromorphic condition, vertical discontinuity, and for the farmer with a description of plant growing conditions, for example, nutrient contents, like example nitrogen, the available water capacity, rooting depth, groundwater condition, and the first level are common available maps: Bodenkarte, topographical map, erosion map, soil evaluation map, Bodenschätzungskarte, and in the next level, this described indicator layer with ECA, with NIR, and so on, yield distribution, and here in the middle, the derivation of this main value of the relevant soil parameters, and the end is a described, here is a described theme layer. The next slide is yes, is only a little bit pictured this the geological map, erosion map, ECA map, quaternary sediment map, and the end is this very accurate soil map. Now, ladies and gentlemen, this is my last slide. This is my last slide. All these maps, the different level of maps, are today used especially for the derivation of soil functions. the derivation of soil functions, are described in the German Soil Protection Act and are also used in the area of precision.